The first step is always to factor the numerator and factor the denominator. So I've done that. And you look for common factors to see if you have any wholes. Well, x plus 3 is a common factor, so that means we have a whole. So to find your whole, you set the common factor equal to 0. Solve for x. So the whole happens at x equals negative 3. To find the y value, you need to write out your simplified version after you've divided through your common factor. So our simplified version is x plus 3 over x times x minus 5. So to find your y value of your whole, you just take the x value you just found and plug it in. So y equals negative 3 plus 3 over negative 3 times negative 3 minus 5. Well, that's 0 over 24, which is 0. So that means that our whole is at negative 3, 0. Go ahead and graph that before I forget. So now I'm going to find the x and y intercepts. So this is the function that we're going to be using, the simplified one. So to find your x-intercept, you make y 0 and solve for x. So 0 equals x plus 3. X equals negative 3, except that negative 3, 0 is our whole, so if it's the whole, it can't be a point, so there's actually no x-intercept. So that's the x-intercept. To find the y-intercept, you set x equal to 0, so 0 plus 3 over 0 times 0 minus 5. Well, that's 3 over 0 times negative 5 is 0. That's undefined, so there's no y-intercept either. So there's no x-intercept and no y-intercept. So now to find my asymptotes. To find the vertical asymptote, I set the denominator of my function equal to 0. So I'll do that here. So to find my vertical asymptote, I set the denominator equal to 0 and solve for x. So x equals 0 and 5. So here we actually have two vertical asymptotes, x equals 0 and x equals 5. So here's x equals 0. Here's x equals 5. 1, 2, 3, 4, 5. So to find my horizontal asymptote, well, the degree of the numerator is 1, and if I distributed this out, the denominator would be x squared minus 5x, so the degree of the denominator is 2, big on bottom, so the horizontal asymptote is y equals 0. So y equals 0, so draw that in. And then we know that it doesn't technically cross the horizontal asymptote because there's no x-intercept, but it does kind of sort of because there's a hole there. So we don't really have very many points to work with, so I'm going to make a table. When I make a table, I choose x values. I choose a, quote, extreme low x value, usually negative 10. Then I pick one that's almost to my first vertical asymptote, but not quite. I'm going to pick negative 1. Then I pick one that's just on the other side of my vertical asymptote, so I did 1. Then one that's almost to my next vertical asymptote. Then one that's just on the other side of my vertical asymptote. Then a, quote, extreme x value, high x value of 10. So this is what my table looked like. So I noticed this point 1, negative 1. So I'm going to go ahead and graph that. And then I'm going to talk through it logically from here. You know that the graph cannot cross the x-axis at all. So if you have this point, and you're going to hug the two asymptotes and you're not allowed to cross the x-axis, it has to look something like this. Because it cannot cross the x-axis. If, for example, it were this red, you would have had an x-intercept right there, and we don't, so it cannot be the red. So it has to look something like this. Now, let's look at the vertical asymptote x equals 0. Well, on the right-hand side of that asymptote, we're going down. So that means that on the left-hand side of the asymptote, we have to be going up, because it is not a double asymptote. It has to kind of go through the hole, and then it's going to dip down below, but it's not going to cross the x-axis again. So it's going to come back up and approach the asymptote from below now. On the right-hand side of x equals 5, well, on the left of that asymptote, that's here, it's going down. So on the right-hand side of the asymptote, it has to be going the opposite direction because it's not a double asymptote either. And then I know that my function does not ever cross the x-axis over here. So it's going to look something like this. So you can either use logic to kind of generally shape your graph, or you can be a little more precise by actually plotting your points as best you can with the table. So the domain is going to be negative infinity to negative 3, and anything between negative 3 and 0, and anything between 0 and 5, and anything above 5.